So yesterday, we left off talking about how to decode some of those paragraphs. But I want to sort of backtrack and make sure that I said this right because I know, bless you, I know that the fact that I make these videos like sort of public, there's going to be some yahoos out there that are going to be like, oh, you said that wrong. So I'm going to just clarify what I said just a little bit. Yesterday I said we use the independent probability where you just multiply the two problems together, and it's kind of like doing it even when it's dependent. That's not entirely true. So I want to clean that up by saying, like, for example, let me just clarify what a dependent event is. A dependent event is something where the second probability, or the second event, is affected by the first event. So an example of that is like if I have a bunch of change in my pocket, and I reach in and I draw a coin, and then I hold on to the coin, I keep it out, and then I reach in and draw a second coin. So that's considered a dependent event because we are changing the total number of coins that are in my pocket because I held it out after the first event. So by definition, that is a dependent event. Now, I think I might have mentioned yesterday that even when that happens, it's kind of like we're using the independent formula, but that's not true. We are doing the dependent formula. It's just that, like, when I say, when I read this, it's read probability of A times the probability of B given that A has occurred. So just the fact that I held it out, and then I have to calculate the next probability, that is saying given that the first event has occurred, because I held it out. So I just want to clarify that, because I know, like, yesterday I was saying it a little wrong. So we're not always using the independent formula. We are, in fact, using the dependent formula every time it's dependent. It's just that we don't always say the words like probability of B given that A has happened. So it's not like probability of drawing a coin given that I've already picked the coin and held it up. So we just don't say that, but that is what it's implying. Okay. So quick review. Quick review on how we ended class yesterday. We sort of ran out of time, but I told you that there's a strategy to these questions, especially when you see like parts of the formula written down. So if you see this slash mark right here, the given part, this is straight up substitution. Like all you have to do is plug it into the formula and figure out which formula it is you have to use. So let me go back and talk about how to tell which formula you have to use. So we did a thing yesterday, kind of like taking an inventory. Both of these formulas, both this one and this one, they both have three parts to them. Now, we can only solve formulas if we know two of them. And we've said that all along. Like anytime we have a formula, if they give me 4 letters, they're going to tell me 3 numbers because it's our job to find the last one. So we do this sort of inventory, and all I do is check off like what they've given me to see which problem has the 2 numbers in it, because that's the formula I need to use. The formula only has 3 parts, so I need to have 2 numbers in it so I can find the last part. The strategy that we did in the paragraph, though, do you guys remember like how I started decoding this? Where did I start from? I actually started from the end. I started from the end because I know that in these types of problems, the final part of the question is going to tell you the 2 events that are happening throughout the entire problem. So we started in the last sentence, we figured out what the 2 events were, and then we just assigned them a letter, A and B. It doesn't matter what letters you use. You can put B first and A second. It doesn't matter. In the end, the formulas will all work out the same anyways. Then we went through sentence by sentence and identified what events were happening. So the first one says probability that someone is under 6. Bam! We said there's the A. So I stopped and I wrote down the probability of A is equal to 0.37. So I did this sentence by sentence. I said the probability that someone can read, that's B. And then it says the word given, so that's the slash mark. And then under 6 is the A. So that second sentence is B given that A has occurred. So that's the one in blue that's labeled down here. Probability of B given that A has occurred is equal to 0.59. And the last one, under 6 is A. We have the word given, so that's the slash. And then can read is B. And so that's the green one down here at the bottom that's crossed out. Now the reason why it's crossed out is because when we did the inventory, we're going to use the formula that only has 2 numbers in it. So there's going to be a formula that only has 1 number in it. So basically we don't need that number. So we go up here We go do our little inventory. What did they give us? They gave us the probability of A. They gave us the probability of B given that A has occurred. And then they gave us this one right here. So looking at each formula, this is the only one that has both numbers in it. So that's the one we have to use. Which in the end, all we really have to do is plug them in and times them. So that's what we did here at the bottom. 0.37 times 0.59 gives you 0.218. And I crossed out this one because that's the one in the formula with only one check mark. So we can't use that formula if there's two unknowns. So that's why I crossed it out, because it's just extra stuff to see if you really understand how to use the formulas. So what I want to do now is I want to give you about 2 minutes to go through the paragraph on number 8, decode it, label all the probabilities, and then see if you can figure out which formula you need to use to calculate the actual probability that they're asking you for. So I'm going to give you like 2 minutes. So what are the two events that are happening here? Someone is at least 80, bam, and then the other one is can drive. So it doesn't matter how you label them. I just put them in order. I say A and B. So as I'm going through sentence by sentence, you got to make sure also you're using the correct notation. Don't just put like A equals and B equals, because that means something totally different. It says the probability that someone is at least 80. At least 80 is your event A. And it says that the probability is 0.015 or 0.15. So probability of A is 0.15. The next sentence, the probability that someone can drive, we labeled that as B. So here's B. Given is the key word that tells us to put the slash. And then here's the at least 80 again. So that's A. So this one is probability of B given that A has occurred. That one is 0.05. Then the last one, the probability that someone is at least 80, down here at the bottom, at least 80 is A. And then given again, given is the slash, they can drive is the B. So this is probability of A slash B. Now guys, I want to talk to you about something before we finish the problem. In the other class, I had a kid that was not using the slash and he was using the word and. You got to be real careful about that. So first of all, the word and is right here. Now the reason why you can't use the word and you have to use the slash is because in your formula, that is going to impact where you put the numbers. So you cannot use the word and unless the problem actually says and. Because if you write down and, that means you're going to plug your number in right here, which is okay in some problems, but that's not what this problem is saying. Matter of fact, when we're done with this, I'm going to show you like what happens when the numbers end up on different sides of the equal sign, because that is going to happen on the test. So let's see what we got here. So inventory time, we've got all the stuff pulled out of there and decoded. So now we just have to figure out which formula to use. So they gave us A, probability of A, they gave us this one, and they gave us this one. So that means, again, we have to use these two, and the two numbers, they're right next to each other, so all we have to do is multiply them. So we don't need A given B, so we don't need this one again. And guys, I know there's a pattern here, but it's not always the last one. So you need to really read through, decode, and verify up in the formula where the stuff is going to go. Because notice on here, it's always the last one. That's not how it works. Got to be real careful with that. Okay? So according to the formula, it says all we have to do is type in 0.15 times 0.05. But then the calculator, I think the calculator says this. Is it -3? Okay, so let me explain what that is. Our calculator, when it works with either really huge numbers or really small numbers, it uses scientific notation instead. And I know scientific notation doesn't use the letter E, but that's what our calculator does. So what that's saying is take the decimal and move it left 3 places. 1, 2, 3. Every spot that's empty that's got this little dip, we fill them with zeros. So the answer to this question is 0.0075. That's the probability. Is that very likely? No, remember our scale is from 0 to 1, right? 0.0075 is very, very close to 0, but still it's not impossible. It could happen, but the chances are not very likely. Okay, so here's what I want to talk about with you next. I mentioned about this pattern, how every time we did a problem, it always ended up being 2 numbers on the right. I want to show you what happens if your numbers end up on different sides. This, I made this all up, so don't get confused. It's not related to the last problem at all. So I'm gonna define some stuff for you. So let's pretend I read my own problem and I decoded it, and I said this instead. A and B equals 0.01, and then the probability of A is equal to 0.5. Okay. Now, number 1, if the problem says and, write the word and. But if it says given, you have to put the slash, because that's going to impact where you plug in your stuff. So according to this, probability of A and B, which is totally possible on the test, it would go right here. The probability of A, it would go right here. So if I substitute in the values, 0.01 equals 0.5 multiplied by the probability of B given that A has occurred. How do I solve for the probability of B given that A has occurred? Like I want it by itself. How do I get rid of the 0.5? Subtract. This is basic algebra. They're being multiplied. You have to do the opposite. 0.5. You have to divide by 0.5. If they're stuck together and they're side by side, you have to divide. So these cross out. Now we can find the unknown probability. This is regular algebra. And guys, if it bothers you that it looks fancy, just make it an X. That's whatever you like. That's the unknown. It's X. You can make it X. I don't care. Did anyone type this in, by the way? I think I might give us another, maybe another E. Oh, maybe not. 0.02. That's our answer. So in the other class, I had switched these numbers. I put probability of A and B as 0.5. Probability of just A was 0.01. So basically, I switched the numbers. And then when we did the math, it gave us 50. Why can't we have an answer of 50? Yeah, it's impossible. It's between 0 and 1. So if you get an answer bigger than 1, you know that something's wrong. You did something wrong. I'm going to also give you a heads up. The other class that left, they were kind of screwing around. Guys, this is important stuff here. Oh, I got to make this comment too. I've already tested it. So please don't waste time like just sitting around messing around on your phones and stuff. Actually do the practice and get your questions answered, because while second hour was doing their stuff, I tried using photo math like someone did on the last test. It doesn't work. So you're going to have to really know probability, because you're not going to be able to cheat on this one. Not only, I'm not telling you to cheat, but I'm saying, like, now that there's cheating going on, now I have to be like a prison guard. I'm going to be walking up and down the aisles. I'm going to go to the dollar store and see if I can find a baton, so I can carry it up and down, so I can check to see if there's bones. I'm not kidding. Like, I love test day, because that's when I get to get work done and update grades. But now that there was cheating going on in the last test, now I'm going to be up and walking and looking over your shoulder the entire time. So stop cheating. There's no reason to cheat. You get a lot of time in class to get help. Now today's the last day of basketball for me. I'm going to be available a lot more after school, and all week this week I've been getting here by like 6:15 in the morning. So yes, I'm not available after school, but I make that availability in the morning. So if you show up at 7:30, come in at 7:30 and get help. There's no excuse. You have also Remind. You guys can send me messages on Remind when you don't understand stuff. So you got the entire period to work on the assignment, and it's due before you leave. So you're going to do 9.4 all, and then tomorrow I'm going to teach you how to read probabilities from a Venn diagram.